camera, fractions.
Lovely.
So much
Okay.
emotion.
All right.
So
So
much motion.
we've already
Emotion.
done.
Emotion.
We've already done a lecture on simplifying radicals, right? Radicals are square roots, or well, I should say square roots are radicals. The reason, did I explain why you would say radicals instead of square roots sometimes?
No.
Because you know how like an apple is a fruit, but a fruit does not mean it's an apple, right? Like a fruit encompasses more. Well, radicals encompasses more than square roots. Radicals encompass cubed roots and quadra roots and 5/5 roots and 6th roots and an infinite number of roots. And so if you think about it, if well, you guys all know the square root of 4, right?
Yeah.
It's 2, right? Well, another way to write the square root, guys, another way to write the square root of 4 is the square root of 2 times 2. Wouldn't you agree with me? So when you have a square root, there's a hidden 2 right here that says I need 2 of the same number to have one of them come out. I mean, to basically have it come out as one of them, right? So, I have 2 2's. They can come out as a 2, and I would write that 2 over here. So my final answer would be 2. If there was something else under here, I'd put square root of that something, but there isn't. So the answer is just 2, right? The square root of 5 times 5 is, square root means I need 2 of the same number for them to come out as one of them, right? So I've got 2 5's that'll come out as a 5. There we go, right? That's clear, right? Everybody understands it?
No.
Yeah.
Well, what's 5 times 5? Well, what's 5 times 5?
10.
25.
So what's the square root of 25?
It's 5.
Right. So that's all I'm doing. I'm just showing you that the square root of 25 is 5 times 5. Square root means you're taking those 2 and bringing them out as 1, because that's what square root means. What number times itself equals that number, right? See what I'm saying?
Yeah.
So, but there's also things called cubed roots, right? So I could say, what is the cubed root? And to do cubed root, I'd have to write a 3 here, right? What's the cubed root of 8? Okay, so right. So what we're going to do is we're going to rewrite it as all the prime numbers here. The cubed root of what's 8? 2 times what?
2.
Times 2 times 2. Oh, it says I have to have 3 of the same number in order for them to come out. So the answer is 2.
But you don't have to rewrite it like that.
No, I'm just showing you. I'm explaining it to you by writing it that way. So when it's asking for a square root, you need 2 of the same numbers to cross them out and bring them outside of the square root sign, right? When you have a cubed root, you have to have 3 of the same numbers to cross them out and bring them out.
What
right?
do you do when you don't have a perfect square?
Oh, shoot, you don't ask questions like that. You never, ever, ever ask questions in my notes. Okay, good question. To have 20 minutes, I tell you what, why don't you stay after and we'll explore this further.
You seem very excited by this.
Yeah, totally.
Oh, you're gonna love it.
Oh, dear.
You're gonna love
Oh,
this.
dear.
Oh my God.
Part of video.
So what would this be? This the 4th root of
16.
93.
Negative 3.
Oh, thank goodness.
Some 4.
4.
All right, it's going to be 4 because 4 times 4 times 4 times 4 is 16. That's 4 of them. It'll come out as a 4, right? What's the cubed root of 27?
9. Oh my God.
3 times 3 is 9 times 3 is 27. So it's 3 times 3 times 3. That's 3 of them, and it comes out as a 3. Right? You get it? It makes sense, right?
Oh.
Well, these are all radicals, but these are not square roots. Square roots have a 2 here, right? Now, because we use square roots the most, we often don't put the 2 there. In fact, almost never put the 2 there. So if you just say that, it's automatically assumed that there is a 2 here. Because most of the time you're dealing with square roots, not cube roots and fourth roots and fifth roots, right?
Country, please.
Right. So anyways, that's why we call them radicals.
That could be a cereal.
Well, I don't know why we call them radicals actually, but that's why.
They taste.
It's just
magically
like, it's like
delicious.
Fruit Loops, but it's 4 rings attached to each other.
Oh,
It's like a
that's
4-leaf clover.
We're starting a
And then
new
you get- yeah.
company.
Okay,
Called
great.
Fruit Loops.
Fine.
Oh my god.
So the lecture would be over right now, except that Gideon asked this question, and I
Thank
feel
you,
like I need to
Gideon.
spend the next 15, 20 minutes going over the answer.
God.
So he asked this question: what if you had something that doesn't have a perfect square root, right? So what you do is you do what's called simplifying, right? Now there's 2 different ways to do it. And one way, I'm going to teach you the other way first, and then I'll teach you the way I taught you last time. The one way is to get it down into its prime factors. Remember tree factorization?
Yes.
Have you ever
It
done that?
was annoying.
So
3 and 4.
So, right, I usually, if it's an even number, I usually put the first one as a 2 right away, right?
2.
2 times what is 12?
6.
6. So you guys would agree with me that 2 times 12 is 6, right?
Yeah.
Now, can I go further with 2?
No.
No, that's a 2 is a prime number, right?
Gary
I
said
can't-
2 times
If
12
I
is
go
6.
like this, I'd have to do 1 times 2, and it's still a 2, right? But the 6 has,
2, 3.
yeah, 2 times 3, right?
Or 6 times 1.
So now look, 2 is a prime number, 2 is a prime number, 3 is a prime number. 12 is the same as 2 times 2 times 3, right?
Yeah.
So I could write it like this: the square root of 2 times 2 times 3. Oh, but this is square root. I have to have 2 of the same number. I do. I have 2 2's. Those 2 2's can come out as a 2. Are you with me?
Yeah.
And they will technically go here. So now I've got 2 square root of 3. So I just simplified that by
2 times 3.
using tree factorization, getting it down to its prime numbers, and everything that was a, that where I had 2 of anything, they would come out. Does that make
Wait,
sense?
Gary, I have a question.
So that's way 1. Yes.
So prime factor is 2 the only even number that is a prime number?
Correct.
If there is an infinite amount of numbers, wouldn't there be another even prime?
Don't
no,
ask
'cause 2 goes
questions
into
like that.
any. Because 2 goes into any.
No, I don't know. That's a good question. I think 2 would be the only
Wait, what about 0?
prime. 0 is not a prime number, nor is 1. 1 is not a prime number, ironically.
Because it's 1 times.
It's like going in.
And
Yeah.
Wait.
What?
something.
But isn't a prime number like the
It's
ult-
1
oh,
times itself.
It's
And
it's
that's
only
the only way to
divisible
get it.
by the number 1 and itself. The reason why 1 is not a prime number, I think, in
Because
my
it's
brain,
only 1 times
because it's
1.
1 times 1. It's the same number, right? So it's like there's not a second number for it to,
Oh, that's.
I know, it's really
that's
discriminatory in my opinion. I feel like mathematicians have really missed the boat on this, but that's the way they do it. Okay.
But
Which way
0
there's
times
that
0
talk show
should
and
be
Okay.
Because
So-
it's always going to.
So that was way number
Oh,
1.
I get it.
This was way 1,
Yeah.
right? My good old famous way 1.
Watch multiply.
So the way 2, the other way I do these, right, is I taught you this. I said, well, let's look for perfect squares that go into 12. Ideally, the biggest perfect square that goes into 12. And perfect squares are 2 times 2 is equal to 4. 4 is a perfect square.
Yay!
3 times 3 is 9. 9 is a perfect square. 4 times
What?
4 is 16 is a perfect square.
Crazy, Gary.
5 times 5, 25.
Oh my
I
god!
know how else can I
25.
Can I do it here?
36,
5.
49, 64, 81, 100, right? Well, because I have the camera on.
It's okay. It's okay.
But you can talk me through it.
Okay,
Okay, guys, listen, please.
so you have to pick the one that is a factor of
Yeah.
12.
Right.
And so that would be, or the largest one is practical, so that would be 4. And so it would just be the square root of 4 times the square root of 3. And then you can simplify the square root of 4 to 2, and so it would just be 2 times 3.
All right, so she said
Yeah,
this.
square root of 3.
So she said the square root of 12. She notices that there is a perfect square that goes into 12, and it's 4. So she said the square root of 12 is the same as the square root of 4 times the square root of 3. Now that is also the same as saying this, the square root of 4 times the square root of 3, right?
But
Yeah. When you have them both underneath the radical sign multiplied, you can separate them and still multiply them.
Okay.
That's legal. That's a legal move. And the
It
beauty
just
of
doesn't
that,
seem legal though.
well, it is. It is. I know, it's kind of, you kind of stretch a little bit. But what's the square root of 4?
2.
So therefore, you're saying my final answer is 2 square root of 3.
oh,
You see what I'm saying?
yeah.
So the point is,
Oh,
we
wait.
could simplify, because we used a perfect square, we could simplify one of the factors. Does that make sense? The square root of 4 became 2, right? Therefore, we were able to simplify. Had we decided to ignore this list of perfect squares over here, we would have wasted our time. Because a lot of people might have tried to do this. They might have said the square root of 12 is the same as the square root of 2 times 6.
Whoa.
And then they say, oh, that's great, that's the same as the square root of 2 times the square root of 6. And then they would realize, but I can't go any further. Right? Because there's no square root of 2 and there's no square root of 6. So it kind of messes us up. Right? So the only way, if you use way number 2, that you're going to succeed is if your first number that you put there is one of these numbers. If it's any other number than those numbers, you just wasted your time. It's got to be one of those numbers. Does that make sense?
Yeah.
Right? So let's try them again with way 1 and way 2 for different.
Wait. Mike wants to take a picture.
Michael, you didn't take a picture? I just erased way 1.
He only has one way.
All right, square root of 12. We said it was 2 times 6 and 2 times 3. Boom, boom, boom. Which is equal to the square root of 2 times 2 times 3. The 2's come out as a 2, so it's 2 square root of 3. That was way 1. Go for it.
He did that so quickly.
It's easy. You got it, you got it, you got it.
Just like this little voice.
So let's try number 2. What time is it? Okay, we're fine. All right. So let's say we have the square root of 32. All right? Square root of 32. We'll try it. Which way do you want to do first? Way 1 or way 2?
Way 1.
Way 1, way 2. Well, all those in favor of way 1 first, raise your hand. All those in favor of way 2 first, raise your hand.
That's no.
All right. So I guess we'll do way 2.
Oh, why?
So honestly, I use 99% of the time I use way 2 because I find it fast, right? Because my brain can deal with some of these numbers, right? Unless if I gave you the square root of 432, then my brain might not choose to do way 2. I might choose to do way 1 because tree factoring would be easier for me to get it down into little bits and pieces that I can deal with. Does that make sense? Right? So square root of 32. Okay, we'll do way 2. All right. What is a perfect square that goes into 32?
16.
Does 4 go into 32?
Yes.
Ah, but you're saying 9 doesn't, but you're saying 16 also does. So which one would you use?
16.
The bigger one, right, exactly. So we're saying, and I always write the perfect square first. 16 times 2, right? You good with me? Make sense, you guys? Right? So that's the same as the square root of 16 times the square root of 2, which is, my final answer is 4 square root of 2, because the square root of 16 is 4. Pretty easy, right? Yeah. Now, I could have done this. I could have started with 2. I could have started with 4. 4 times 8. 8 is 4 times 2. Oh my God, I don't even have to go to prime here. Look, I've got 2 things that match, right? So suddenly I can say the square root of 32, whoops, excuse me. The square root of 32 is the same as the square root of 4 times 4 times 2. Right? You see what I'm doing?
Yeah,
This is
we
way,
build a two.
this is way 1, right?
You didn't circle the 2.
I didn't start with a 2 because suddenly I
You
thought,
didn't circle
oh,
the two.
You didn't circle a 2.
Oh. I see. Yeah.
Thank you.
Thank you. Right? So this is square root. I have to have 2 of the same. Those are going to come out as a 4. So my answer is 4 square root of 2. Pretty easy either way, right?
Yeah.
You don't have to go down to prime. Now I could have gone down to prime. If I had gone down to prime, this is what would have happened. This would have been 2 and 2, right? I'll circle them because I know Gideon gets giddy if I don't, right?
Gideon
So-
is happy.
Oh, well, whatever. Okay, you're always happy. Okay, so now, wouldn't you agree with me? 2 times 2 times 2 times 2 times 2 is 32,
Yeah.
right?
Yeah.
Okay, so
Yes.
square root of 2 times 2 times 2 times 2 times 2 is
Oh, yeah.
32, right? Oh, but this says the square root of anything that I have 2 of can come out as 1. There's 2, that comes out as a 2. There's 2,
Oh,
that
no.
comes out as a 2.
Oh, it's all alone.
Kill me now.
So suddenly it's 2 times 2, which is 4 square root of 2. It works anyway. It's easy, right? Okay, can I erase?
No.
Do you need to take another picture?
Yes.
Get that. No, you got it. Okay. All right.
Wait, no.
All right.
Oh, I haven't written any of this down.
Well, your hands are on your hat.
Here you go.
Oh, he has. You can copy his.
Good.
Pay attention and write it down.
But
Use your head.
What?
Gideon, I think you get it.
Come on. The
I
pencil.
don't have it.
Well, then grab your pencil. Here, I'll try and move your hands.
It's I see numbers differently than I do words.
Alright, here, wait.
I don't know
wait.
why.
I want to see
Okay.
if I can write use doing
Okay.
this strategy. I want to see if I can write doing this strategy.
Okay. So now I have like 8 minutes left. Okay.
Go, go,
And
go.
we really need to focus now because now that you understand, do you guys understand the simplifying radicals pretty well? It's pretty straightforward, right? Fist of 5, just so I know. Okay, awesome. Okay, good.
Here,
All right.
copy off mine.
So now we got to talk about adding radicals, okay? And adding radicals is you actually know how to do it as long as you know how to simplify radicals. But first of all, let's talk about this. Let's say I had 2 times the square root of 3 plus 5 times the square root of 3. Now, let's think of what that means. This says I have 2 square root of 3's. Technically, that means I have square root of 3 plus the square root of 3. I have 2 of them. That's what that means right there. 2 square root of 3 means I have 2 of them, and I'm adding them together. Plus, this says I have 5 square root of 3. So square root of 3 plus the 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 square root of 3. I have 5 of them. So can I add them?
Bye.
How many square root of 3's do I have?
7.
Oh yeah, you're right. There's 7 square root of 3's. So if as long as my radical sign is, what's under the radical sign is identical, then what are these called again?
Yeah, I forget.
Base.
Nope.
Variables.
What?
Whoa,
That
what am
was
I thinking?
Coefficient. 25.
Coefficients, right? Oh, sorry.
Coefficients.
I thought you said tangents.
I just
Coefficient.
died.
Tangents.
Right? All right, coefficients, right? As long as the number under the radical sign is identical, you can add the coefficients. So 2 plus 5 is 7, so it's 7 square root of 3. So that's really pretty easy, right? So let's try a couple. What if I gave you 4 square root of 3a plus, 6 square root of 3a? what would be my answer?
10 is the square root of 6A. 3A.
Six,
Do
six,
that. Yeah.
Right?
6A.
You don't change. You don't change what's under there, right? Under that radical sign, you're adding. You're not changing those things. I have 4 of the 3A's, 6 of the square root of 3A's, so I have 10 of the square root of 3A's, right? What if I gave you this? 2 square root of 16x, not 16x, sorry, 15x. I don't want to get, okay, minus 7 square root of 14x plus 3 square root of 15x. What would that do for me? Guys?
You can only simplify
You would have-
15x.
You would have.
What are you what? What? What?
5.
Are you sure?
5.
No,
Yeah.
say,
Well,
say,
yeah, you
so
can't
what are
have
you,
them.
so,
No,
so,
you
so,
can't
so
do
London,
that.
London, keep going. So what can I combine?
You'll get 5 and then the square root of 15x.
Yes, okay, good. 5 square root of 15x.
And then minus 7 square root of 14x.
So do you guys see that? That this one does not have an identical number under the square radical sign, under the square root sign. Therefore, that's off in left field. London saw that. He only looked for the ones that were identical, and then he was able to add his coefficients that were in front of those identical radicals, right? Perfect, that's perfect. This one, so you just have to keep them separate now like that. That's it, that's as far as you can go, right? Okay, so now, but what if the number under the radical sign is not the same, right? That is the question. So what if I gave you
Blue.
a
Be or
pro-
to not to be or not to be.
That is the question.
That is
There
the
no one to
question.
live, I know not.
Yes.
I failed.
Okay. So what if I
Fail
said
English
the
like I
square
failed math.
root of, hang on one second, let me think about this. 75,
Step off, man. Step off.
the square root of
21.
27.
21.
All right. So what if I asked you to add that? Can I add it the way it is? No, because those numbers have to be identical. But could I try simplifying and see if something works? Okay, is there a perfect square that goes into 75?
Yes. 25.
25. So this is the same as 25
Times
times
3.
3. Okay, plus, is there anything that goes to 27? 9. Okay.
Oh
So
yeah,
that's the
now
same
9 is the answer.
as 9 times the square
I
root
was
of 3.
thinking it's 9 times, it's 3 times 3 times 3 again.
So what is this? 20. What's square root of 25? 5 square root of 3 plus 3 square root of 3. Ah! I have the same numbers now under the radical sign. So what's my final answer?
He got so
8 squared
excited.
root of 3.
8 square root of 3. Right? You see that make sense? Okay, so now I'm going to make it a little harder because there's not a whole lot to make. Okay, I'll just do it over here. Let's say I gave you 4
How you doing?
square root of 12. Let me think here.
Think,
Okay.
Gary, think.
Plus,
Here.
sorry,
You
Plus,
okay, Gideon? You're
3 square root of 27.
Hi.
Okay, that's fine. That should work. All right. So obviously the numbers under the radical signs are not the same. The question is,
3 and 4. And 3 and 9.
all right, so I could do 4 times the square root of 4 times the square root of 3, right? Wouldn't that be the same?
Yeah.
Okay, plus 3 times square root
9
of 9 times the
times
square root of 3. All right, so what is 4, square root of 4?
2.
So what would that 2 do to this 4?
8.
2 times 4 is 8. Square root of 3 plus
17.
3 times 3 is 9 square root of 3. You with me? Does that make sense?
Yeah.
Because the square root of 4 is 2. 2 times 4 is 8. The square root of 9 is 3. 3 times 3 is 9.
Gary, be sure to email us the video tonight.
Okay.
Okay? You with me?
Yeah.
Okay, tell you what.
17
I'm not gonna go quite so fast. You get 4, 4. Square root of 12 is the same as the square root of 4 times the square root of 3. I'm using my perfect square first, right? You with me? You guys see that?
Yeah.
Oh, that's right. It's time. Okay, but hang on. And then square root of 27. 9 goes into 27. 9 times 3 is 27. So then there's that. Now I'm going to just go one step further. 4 times square root of 4 is 2. And then I have my square root of 3 plus 3 times square root of 9 is 3 times the square root of 3.
Which is 8.
So 4 times 2 is 8 square root of 3 plus 3 times 3 is 9 square root of 3. Ah, now I have the same radical sign. 8 plus 9 is 17, right? 17 square root of 3. That makes sense? You get it? You see it?
Yeah.
So all I did, the only thing is I added this 4 in front of the square root sign. The key is you can pretend like it's not there at first, like I did over here, right? But then whatever comes out gets multiplied times that number. Does that make sense? Okay, that is it, guys.